Okay, so today we want us to look at um, finding area of shaded region, finding the area of the shaded region. So the concept here is simple. The concept here is so simple. The concept is area of larger shape, take away area of the smaller shape. So what I mean is, if you are finding the area of the shaded region, you use the area of the larger shape, take away the area of the smaller shape, or area of the larger shape minus the area of the smaller shape. So that's the concept that I am going to be applying here. I wrote it there on the board. Okay. So let's look at this question. I took it from a past paper. All right. So this question reads, the diagram shows a shaded ring formed by cutting a smaller circle out of a larger circle. The radius of the smaller circle is 6 centimeters. So what I then do is I like to draw, right? So what they are saying is that the radius of this smaller circle, the smaller circle is the one that is inside this one. That's the smaller circle. Okay, that's the smaller circle. So they're saying the radius of that smaller circle is 6 centimeters. All right, that is the radius of the smaller circle. Then I come and then I write down. So I'm just gonna say SC, standing for smaller circle. Then I'm gonna say is equal to 6 radius. Okay, because I will need this information. I will need this information. Okay, and then what else did they say? So I have written that it is 6 there. All right, so then they say the diameter of the larger circle. The diameter of the larger circle is 15. The diameter of the larger circle. So let me use a different color here. I'll use red. So this is, let's assume this is the diameter of the larger circle. So they're saying the diameter of the larger circle, the outer circle is the larger circle. This one, that's the larger circle. All right. And its diameter, they say is 15. So I'm gonna say larger circle, LC, is equal to 15 centimeters. So 15 centimeters happens to be the diameter. And you know that radius and diameter are two different things. Okay. All right. So this is the information that I needed, which is provided right there. Okay. So they say find the area of the shaded ring. So that's when the concept comes in play. This one, that's the concepts that I'm going to be applying, all right, which is area of the larger shape, take away the area of the smaller shape. All right, so how many shapes do I have here? I actually have two shapes, the smaller circle and the larger circle. So shaded area is gonna be equal to larger area and in this case I mean the area of the larger circle. Okay, take away area of the smaller circle. So this is basically what we are going to be doing. All right. So I'll start by finding the area of the larger circle, the one that is in red. That is my larger circle, right? So you know that the area formula for a circle. Okay, I'm going to just write it here. The area of a circle formula, the area of a circle, you need to know that formula by head. So the area formula for a circle is pi r squared. It's pi r squared. Okay, this is the formula for area of a circle. So this is what I'm gonna be applying here. So we have got two circles, the smaller circle and the larger circle. So I'm going to find the area of the larger circle. Okay, and then I take away the area of the smaller circle in order to find the shaded area. Okay, so area of the larger circle, remember I said this is the formula, pi r squared. So I'm just gonna say pi, right? So what is r, what does r stand for? So r stands for radius. But if you come here, they said the larger circle has a diameter of 15. That's why I had to write it down so that I don't mix up. Okay, a lot of students they always get it confused. They they either write diameter instead of radius or radius instead of diameter. So this is very, very important. No wonder it's very important to take note of um, the important information that is given. So I know that the larger circle has got a diameter of 15, okay? But in this case here, the formula for area of a circle that I'm going to apply here is pi r squared, and it has got radius here. There's no diameter. So what I need to do is I need to find the radius because I know that radius is half of the diameter. So if the diameter is 15, that means the radius is going to be half that 15, which is 7.5 squared. So then here, then I write 7.5. Okay, then I say squared, right? And I say take away. Now I'm working out the area of the smaller circle. The formula of the area of the circle doesn't change, whether it's smaller or larger, it remains the same, pi r squared. So they told us there that the smaller circle is a radius of 6, and I even wrote it here so that I don't um, miss out that important information that was provided. So the smaller circle is a radius of 6 centimeters. Therefore, now I just impute the given information into that formula, pi r squared. All right, so the area of the smaller circle is going to be pi. My radius is given is 6, so I don't need to halve it because it's already um, radius. Okay, it's not diameter, it's radius that is given. So the radius is 6, so I'll just impute it into the formula. Okay, like so. This is what I now have. Okay, then what's next? Now work it out. So 7.5 squared times pi. This I can just write it as a fraction. I can just write it as 81 over 4 pi. Okay. That will be the answer there if you work it out. So I just said pi times 7.5 squared minus pi times 6 squared. Okay, I subtracted the two together and then it gave me 81 over 4 as a fraction. So you say that again, leave it as a fraction. Okay, or I can leave it as a decimal, and as a decimal, if you work it out, realize that it is gonna give you 63.6 centimeters squared. Okay, yeah. All right, so that's basically what I did there. That's basically what I did. I first worked out the area of the larger, then I subtracted the area of the smaller, which gave me 81 over 4 pi, or 63.6 centimeters squared. Okay, so that's how I worked out the area of the shaded region. All right, so now let's go on to another question, and I'm just going to be applying these concepts, okay, of area of larger minus or take away area of the smaller. That's basically what I'm going to be doing, okay? All right, there it is. That's that's the question that we want us to look at. So this one is a little bit different though from the one that we just did. But the concept still remains the same there. So it says the diagram shows a semicircle inside a sector of a circle, ABC. All right. Then they say AB is the diameter of the circle. So this AB here is the diameter of the circle. And they say angle BAC, BAC is equal to 90. All right. So they're saying this angle over here is equal to 90. And then they say AB is 12. So that means the length of AB is 12. Then they said find the area of the shaded region. Find the area of the shaded region. All right, first things first, let's write down the most important information. Okay, so the radius of the semicircle, the radius of semicircle they say that is 6 centimeters. So mm, this, because the radius is going to be 6 centimeters, because the diameter right here is 12, and you know that radius is half of the diameter. Okay, so radius of the semicircle here is going to be 6 centimeters. Okay, which is the most important thing to do. And then now I can find the area of the semicircle. I will find the area of the semicircle. Then I'll also find um, the area of um, of but they say it's a sector, and a sector is a quarter. Okay, sector right here, it means a quarter. Okay, so what I'll just basically do here is that I'm going to apply that concept that I told you about. So what I'm going to do is I'm going to find the area of the sector. No, sorry, the area of the quarter of the circle. Area of the quarter of the circle. Area of quarter of the circle there. Then I'm going to take away the area of the semicircle. Then I'm going to take away the area of the semicircle. Okay. Why? Because you can see that the quarter circle, which happens to be the sector, right, is actually the larger shape. All right. So if we're talking about sector, you can see there, that's the sector that I'm drawing here. So that is the larger shape. So remember, area of the larger, take away area of the smaller. Remember our concept? That's exactly what I'm applying here. Okay? And then area of the semicircle is, let me use a different color so that you can see the semicircle. This is the semicircle we are talking about. All right. This is the semicircle we're talking about. You can see that the semicircle is actually inside of the sector, or it's actually inside of that quarter circle. So that makes it smaller. It makes it smaller. All right. So now let's find the area first. The area of the quarter circle, which is the larger shape there. So the area of the quarter circle. What I just need to do first is also to find, just like what I did there, to find the radius of the semicircle. I can also find the radius of the quarter circle, which is given right here. They say it is 12, isn't it? All right. So, so the radius of the quarter circle, radius of the sector or the quarter circle is equal to 12 centimeters, all right? It's given. This information is given. Okay, so therefore, the area of the quarter circle, we know the area of the full circle is pi r squared. Okay, so this is the area of the full circle. But if it's a quarter circle, I then divide by 4. I take the area of the full circle and then divide it by 4. So this becomes the formula for area of the quarter circle. Okay, pi r squared over 4. Okay, so if I'm to impute the values into this formula is gonna be pi. What is the radius? The radius is 12. The radius of the quarter circle there is 12, okay? So I'm then gonna put 12 squared right there, which is my radius. So it was important for you to first find the radius of the quarter circle. It was very important. Okay, then I say over 4. Over 4. All right, so if I put this in the calculator, I'm going to get 36 pi. So I'm gonna get 36 pi. So let me just leave it in terms of pi for now. I'm going to leave it in terms of pi for now. So this was the area of the quarter circle. The quarter circle, because sector means quarter. So we had to first find the area of the larger shape. And in this case, the area of the larger shape is the sector, which is a quarter. So we had to find the area of quarter circle, which gave us 36 pi. Okay, so now let's find the area of a smaller part, which is the semicircle in red. So you can see that the semicircle there is in red. And so let me use red here. So this side here happens to be the diameter. So AB is the diameter there. So for me to find the radius, I had to divide that 12 by 2. And then I got 6 right here. So I already have my radius. So now it's gonna be easy for me to find the area of the semicircle. So I know that the radius, let me write it here. The radius of semicircle we did calculate it, is equal to 12 divided by 2, was that AB is the diameter of that semicircle. So I'm working out the radius, and the radius is the half of that diameter, okay? So that gives me 6, okay? That's the 6 that I had found here. Just had to repeat so that you understand where that 6 came from and why I had to divide that by 2 is because I need to find the radius. I need to find the radius, okay? Need to find the radius. So I just needed to zoom it a little bit. Okay, so now that I have my radius, now I need to find the area of the semicircle. So I can just write here, area of semicircle. So what does semi mean to you? Semi means half, isn't it? Yeah, that's what semi means. If something is semi, it means it's half of the full, right? So that means if the area of the full circle is pi r squared, okay, if it's the area of the full circle is pi r squared, therefore the area of the semi or the area of the half of the circle, I'll just simply divide it by 2. Okay, so this will be the formula for the area of the semicircle, pi r squared over 2, because semi means half. Okay, yeah. So I had to divide this by 2. So now let me impute the values into this formula. I will then have pi. So I already got my radius. Remember what our radius is? Our radius is 6. So I'll just impute the 6 inside. Then this would be squared. So I'm just gonna leave my answer in terms of pi, all right? Oh, then I divide by 2. Okay, I had forgotten about the 2 there. All right, so what do I get? I get 18 pi. I get 18 pi. Okay, there you go. So I'm done finding the areas of the two shapes. So the first shape was the area of the larger shape, which happened to be the area of the quarter circle. Then we then worked out the area of the smaller part or the smaller shape, which happened to be the area of the semicircle. So now I'm subtracting the two to, I'm going to subtract the area of the smaller shape. I'm going to subtract the area of the smaller shape from the area of the larger shape. Okay, so that's what I'm going to do next. All right. Just trying to look for some space where I can write this down. Okay, I think I can do it here. So now the area, the shaded area. So I'm just gonna write it here, shaded area. Oh, let me just write it here. There's space. Yeah. So let me just draw as I conclude on this. So shaded area is equal to, so what was the area of my larger shape? 36 pi here. So I'm gonna write 36 pi minus the area of the smaller shape was the radius, right? Or was the area of the semicircle, right? Which is 18 pi. Then I'll say minus 18 pi, which then gives me a 36 pi minus 18 pi will give me 18 pi. Or I can just leave it in decimal form to one decimal place, okay? Which is going to be 56.5 centimeter squared. All right. Okay, I'm done. I'm done. All right. So you see that I just applied that concept, area of larger, take away area of smaller. That's the concept. Okay. So now let's move on to the next question here. This question. All right. I'm going to try to zoom it up a little bit so that you can see it. All right. Okay. I think that's better. Yeah, that's better. All right. So this one is also kind of different from the other questions that we uh we have looked at, but the concept remains the same. The concept remains the same. All right, so let's read this question together. All right, so this question reads, a circle is enclosed by a square as shown in the diagram. Each side of the square measures 8 centimeters. 8 centimeters. So they're saying each side of the square. You can see the square is the shape that is the outer shape or the larger shape. All right. Yeah, the outer shape or the larger shape there, that's the square. That is the square. All right. So they are saying that each side of the square measures 8 centimeters, and you know that a square, all the sides of a square are equal. all the sides of a square are equal. So that means there is 8 there, 8 there, 8 there, 8 there. All right. So, and tick this part to show that I've understood it. Then they said, find the area of the shaded region. Find the area of the shaded region, then give your answer correct to one decimal place. All right, it's correct to one decimal place. So that means if I was to find the diameter of this circle, right, before we even think of anything else, let's first find the radius of this circle. So of course the diameter of the circle is 8, because you can see that from this point here up to this point over here is the same in length with the point from here to there, or from here to there. You can see that, right? So meaning to say that the this diameter of the circle is going to be 8. That's the diameter, okay? But for me to work out the area of the circle, I need radius. Okay, I need radius. So I'm then going to say radius of circle, radius of the circle, radius of the circle is equal to 8 divided by 2. So it's going to be 4. So I found my radius over there. So my radius is equal to 4. All right. So what is next? Um, so what is next is for me to find the area of the larger shape. And then I also find the area of the smaller shape. Then I subtract them. Okay, I need to subtract the area of the smaller shape from the area of the larger shape. So by just looking at this diagram, you can actually see that the larger shape happens to be the square, because the circle is inside of the square. So first I need to find the area of the square. Okay, so I'm going to area of the square. All right, area of square. So the area of the square, you know that a square is side times side. That's the area of the square formula. Side times side. And each side is 8, so it's just going to be 8 times 8. 8 times 8, which is going to be 64. So I found the area of the square, okay, which is fine. Now I need to find the area of the circle. Okay, so now I'm finding area of circle. We need to find the area of the circle. So for me to find the area of the circle, I just apply the formula for area of the circle, which is pi r squared. And I've already calculated my radius there. Okay. So I'll just impute the values. So this is pi. What is my radius? My radius is 4, then squared. Okay, so what do I get? All right, I get all right, I get 16 pi there. Let me just leave my answer in terms of pi. Just leave my answer in terms of pi. All right, so the area of the circle is 16 pi, as you can see there. Then now I take the area of the larger, take away the area of the smaller. So this is the 64 is the larger shape. So now I'm finding the shaded area. I'm now finding the shaded area. I'm finding the shaded area, which is area of larger minus area of smaller. Okay, area of the larger shape minus the area of the smaller. And this was my larger shape. So I'm going to write 64 here. Take away the area of the smaller, which is 16 pi, minus 16 pi. Okay, so the final answer is going to be 64 minus 16 pi is 13.7. 13.7 to one decimal place, centimeter squared. Okay, so that's basically how you work it out. So whenever you are finding area of the shaded, always remember that it's always area of the larger shape, take away area of the smaller shape. All right, so tell me what you think about this topic, and also try to find some questions that you can try by yourself, applying that concept that we have just touched today. All right, so that's basically it. Cheers, bye bye.